One of the big ideas in calculus is how fast one variable changes with respect to another. You're already acquainted with this idea anytime you're in a moving vehicle. As you move, you notice that your position changes as time changes. You quantify this change using speed. So let's take a look at that change. What I have here is a table of time from 0 to 6 seconds and position, s of t in feet, from 0 to 20. So what this means is at time 0, you were located at a position of 0 feet, and as time went on, you went from 10 feet to moving 14 feet to having moved 20 feet. So what we want to know is how fast is the car moving from t equals 2 to t equals 4 between this point and that point. So the way we find speed is we look at the change in distance and divide that by the change in time. So in our case, the change in distance, the car went from 10 to 14, so we can find the change in distance by subtracting 14 minus 10, and we can find the change in time by subtracting 4 minus 2. When we do that, we get 2. Since we divided feet by seconds, that means that the units on this is going to be feet per second. The per indicates that we were dividing the units, we were dividing these quantities. What if we look at how fast is the car moving from t equals 4 to t equals 6? Now we're looking at a different set of points, but we can still figure out the change in position and the change in time. The change in position, or the change in distance, is 20 minus 14, or 6, and the change in time is 6 minus 4, 2, and that gives us 3 feet per second. So the car is speeding up and continually changing speed. Since we are examining the motion over a fairly large time interval, the speed is an average of the time interval that we're working with. We went from 2 to 4 at 2 feet per second, 4 to 6 we were doing 3 feet per second, but in reality those speeds were kind of probably continually changing. They just didn't go abruptly from 2 to 3. So the way we define the average rate of change of any function, not just the position function we were talking about, but now we're talking about any function, f of x, with respect to x, is we do f of b minus f of a over b minus a. So that means we take b and put it into the function, we take a, put it into the function and subtract it, and then we divide it by b minus a. Let's take a look at an example like that. In this particular example, the variable x refers to minutes. F of x refers to gallons. So at 0, we can think of a tank having leaked 0 gallons. After 5 minutes, it's leaked 50 gallons. After 10 minutes, it's leaked 90 gallons. And after 15 minutes, it's leaked 115 gallons. What we want to know is the leak getting worse, and why do we think it's getting worse, or not worse, as the case may be. So what we're going to do is we're going to look at the average rate of change of this function over several time intervals. We're going to go ahead and do f of b minus f of a, and then divide it by b minus a, where we're going to get to choose what a and b are. So since the numerator is in gallons and the denominator is in minutes, when we do the average rate of change, we're going to get gallons per minute. And this describes how fast water is leaving the tank over time. It's telling us how the gallons are changing as the minutes change. First, let's look at the interval from 0 to 5. So when we look from 0 to 5, we're going to do f of 5 minus f of 0 over 5 minus 0. F of 5 is 50. F of 0 is 0, so we need to do 50 minus 0. And we're going to divide that by B minus A, which is in this case 5 minus 0, and we get 10. And remember, the units are gallons per minute, so over that interval, the leak is averaging 10 gallons per minute. If I go from 5 to 10, now we're going to do F of 10, which is 90, F of 5, which is 50. We're going to subtract those and get 40. And then we'll do 10 minus 5, which is just 5, and 40 over 5 is 8. So now it was leaking over the first 5 minutes at 10 gallons per minute. Now it's leaking at 8 gallons per minute from 5 to 10 minutes. If we go from 10 to 15 minutes, now we're going to do F of 15 minus F of 10 divided by 15 minus 10. And we see from the table we get 115 minus 90 divided by 15 minus 10, which is 5 gallons per minute. The leak is initially averaging 10 gallons per minute and drops down to an average of 5 gallons per minute, so that means the leak is actually slowing. If this is a big tank, as more water leaks out, there's less pressure pushing the water out, so it kind of makes sense that the leak would get slower and slower as time goes on.